Hello.
Hey,
Hi, Sarah.
how are you?
Good, and you?
Pretty good.
I figured out how to do it, so I feel really smart.
Yay. I know I was like, okay, I'm not even gonna try because when I do it, I don't know if it's like the right one, you know?
So
But
I guess all you do is just go to your YouTube and you go to live streaming. You click event, and then you just takes you to Google Hangout. And what it's basically doing, it's just recording this into a video, And then you go down to the links at the bottom, and you just paste it onto the discussion board.
oh, okay, gotcha. So it's all under YouTube then instead of going to your Google
Right.
Hangout.
It combines it because it's well, if you go to your, your Gmail, use the apps, you just go to YouTube and then go from there.
Uh-huh.
But
Okay.
I guess Josh
Huh?
too busy in Disneyland.
Yeah, I figured since he didn't text us back, he's probably still having fun.
Oh yeah, I wouldn't want to join in either.
Mm-mm. Nope. So I
Yeah,
don't blame him.
yeah. You excited for the exam?
Uh, I'll be glad when it's over with.
Yeah. Are you stressed?
Huh?
Are you stressed?
A little bit. Like, I think if this was the only exam I was taking this week, I'd be fine. But I had to take one on Friday, one yesterday, and then one tomorrow. So it's just kind of stressful.
So you're taking the one tomorrow is in this class?
No, all of them are in different classes. So
Oh wow.
yeah. But are you stressed for this exam or so?
Well, I guess we'll see how it goes. I mean, you gotta have confidence, I guess.
Yeah, I guess, hopefully after this review, we'll feel a lot better. So,
Yeah. Yeah, you ready for the review?
mhm. Yep,
All
I'm
right.
ready.
Let's see what we can do.
So, should we just go to our quiz then?
Yeah, I think that's what we do.
Okay.
Just go to the quiz and then we'll start in.
Alrighty. And then it's group meeting quiz. And it's a lesson 8 group meeting quiz, right?
Yep, that's correct.
Okay, perfect.
Correct. Alrighty.
Ooh, 31 questions.
Oh, are you serious? It's like an exam.
Yep. I don't like she hasn't mentioned about how many questions are going to be on the exam, has she?
Oh, I don't think so. They're
Okay.
probably, I don't know, 40 or so. I mean,
Yeah.
I'm imagine it would be.
Yeah.
Or like there's one
Yeah.
question. No, it's really hard.
Um, so if I heard or read correctly, she basically said our quiz for today is pretty much the exact same thing as a review that we did.
Yep, it's basically the review for the exam.
Okay,
So it's not any new material.
sweet.
We don't do that till Thursday. So today is just gonna be a review over the past 7 lessons or 6 lessons. that we've had, so nothing to stress about.
Sweet.
All right.
Let me just pull up my, because I didn't copy and paste my, like the questions. I just had the questions pulled up and then typed in the answers,
Oh, did you review it? I gotcha. I did
Word
mine. Well, right. I gotcha. I got you.
Okay. Get that pulled up. Okay, now I'm ready.
All right. First one is a freebie. Yes, true. Alrighty. Are you ready? All right. Question 2. Which of the following variables is or are categorical? The number of animals in the local zoo? No. Randomly selected brand of toothpaste at a convenience store?
Yes.
Yes. That is the only one I believe, because the age and years.
Our numbers.
Yeah, quantity.
Mm-hmm.
I just remember, I think my telephone numbers and different things like that is categorical, because unless you are specifying about a certain number, then it would be quantitative, but just kind of a trick, I guess.
Yeah.
All right. Oof. These ones are tricky. The statistic and the parameter. The mean IQ score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112.
Oh, now I remember looking this up, and
Yeah.
so isn't parameter is the like the not true number or something?
Yeah, it's
Or no, sorry, statistic. That's what I meant. Statistic.
yeah, it's any number. Right here, I have it that describes the population, and the statistic is a number that describes a sample. Doesn't really help a lot, I know. The number that describes a sample. So the mean IQ test score in the United States is 100. Okay. 20 randomly selected statistics students took an IQ test, and the mean score was 112.
So the 112 would be the statistic, correct?
I think so, yeah. 112 is the statistic, because I think it's more of a study or a sample, because I think parameter is more like the whole part,
Yeah. Yeah, that's right.
and then the statistic is more of the sample.
So 100
I
would
think.
be the parameter, and then 112 would be statistic.
I believe so. I think 112 is, whereas it is a statistic,
Yeah.
because it's describing the sample.
Yeah. Yeah.
Whereas
Agreed.
parameter is the population, meaning the mean IQ score. So it's the whole, like the population is 100.
Mm-hmm. Okay. Number 4, Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? Some of these that I was doing on the review, I don't know, they all sounded so similar to
They
be,
do.
yeah, you know.
All I remember is like clusters. I remember clusters when you take the sum of everything, and then you're putting it in blocks. Stratified, the way it differs is that you take a simple random, and then they put in their own groups, like the homogeneous groups, according to see if they're freshmen, sophomore, junior, seniors. and then you
Okay.
take a sample from that. Then systematic, I
Is
remember
it the nth number?
every Kate or every nth number, say, or every sixth interval, I'm gonna get to 100. So I go 6, then 12.
Okay.
Then a simple random is just putting all the information from everybody and then randomly sampling people. So,
Okay, gotcha.
so it's not a convenience is not on here, but convenience is just well, convenience.
Yeah. What's convenient for you? Well, as
Yeah,
the sampler.
right. I guess if you're like on the street, okay, let's ask these 5 people. That would not a very good sample, I guess.
Yeah, not so much.
I'll read this question again. It's kind of tricky. Property values are very similar within each neighborhood, but very, very from the neighborhood to neighborhood. One neighborhood has very low property values. And, okay, property taxes are usually roughly proportional to the property values. Hmm.
Do you think it might be cluster because there's 4 different neighborhoods and you're trying to figure out
Yeah,
if they all
it's 4.
like what they all think?
Yeah, I don't think it's definitely not systematic or a simple random right now. It's between a cluster and a stratified.
Well, it probably wouldn't be stratified the nth number, or is that systematic?
It's systematic.
Oh, okay. Gotcha.
I just remember
Hmm.
system because I was like, oh, wait, because it's kind of like a system. Um, you're going, you have like a system going. Like you just think of a number you put into it, and that's how you get it. Like a
Oh,
system.
that's a good way to remember it.
Yeah, you have a system with numbers to evaluate the answer. Um, my notes, I put stratified sampling when items need to be organized into groups homogeneous, similar to items called strata. Then a simple random is drawn based on members who share simple attributes, characteristics, best if they are subgroups. Well, it sounds like they are subgroups. I mean, they're all kind of put into their own 4.
Mhm.
I just don't know if it's a cluster. It kind of confuses me sometimes because cluster can also be somewhat similar.
Yeah, I know. Um, hmm.
What talks about clusters, you're taking heterogeneous groups or different groups and you're putting them together in groups. And I don't think it's doing, well, I guess actually it would be stratified. Almost sounds like it would be stratified because all these people have different values according to where they live. They're all
Yeah, and
the
then
same.
you would take a simple random sample after
Mhm. Yeah,
gathering.
you gather all the information of the 4, and then you get a simple random to get a non-bias for all the data.
Yeah. Should we go stratified then?
I think so. I think it makes sense. If not, it's a cluster, but
Yeah. One or
I
the
think it's
other.
okay. Question 5. When a designed when design experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted, and all the students in selected classes, which type of sampling scheme is implemented. It would, what would you say it is?
I I wonder if it's between the simple random sample or the oh, what was the other one? Or the possibly cluster,
Yeah,
but maybe it's
randomly.
not the simple random sample because it's all
Yeah,
all of 4th grade.
yeah. Could be cluster. Says when design experiments are conducted in a public school system, researchers typically choose a particular district So it's a particular one. So the
Oh,
cluster, but
oh, but they only have simple random sample, voluntary, systematic, or stratified. Oh, or cluster.
and
Never
the
mind.
cluster.
I didn't see that one. Okay.
The experiment is then conducted using all the students. So you're talking all the students. It's not a stratified because they're not splitting them up. Voluntary, that's not a,
Yeah.
not systematic. You think it's cluster?
Yeah, because if they,
Let's see.
because I mean, if they choose a particular district, but then they sample all of them.
Or would it be simple random? Makes me wonder about that too. Because I don't know if they're like putting them into clusters either. They're just taking all of the population. So a simple random too is taking all, at least what's there. I don't know. Kind of confused me.
I know. Hmm. They randomly select teachers, but then they conduct using all the students. So yeah, maybe it might be a simple random sample.
They randomly select teachers of, say, fourth grade students in the district. Okay, so they're randomly selecting different different teachers. Oh, okay, so in these
So
selected classes, so it makes me wonder if it could be a cluster because it is different. I don't
uh,
know. I think it could be a cluster. What do you think?
well, because yeah, I mean, it could be simple random sample, but then again, like we said, it would almost be like you're just out on the street, asking whoever. So it probably wouldn't be the simple random sample.
Yeah.
So we're debating between cluster and stratified or stratified.
Yeah, I think it could be cluster. I'll go with that one, I guess. Do we get to take this 2 times? Or
I don't know if, I mean, all of her other quizzes have been twice, so
maybe?
hopefully. Yeah.
Yeah. At least we'll get to see though, right, for the exam.
Yeah. Okay, so cluster, you think?
Cluster, I think so. It's either cluster or system or simple random. But I think since they talked about different classes and it's not homogeneous, these classes will all be different from. So
Yeah.
so I think it could be cluster. But I could be wrong.
Okay. All right. Number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Wouldn't be a simple random, maybe? Because it's not talking about every,
Yeah. Yeah, that's right.
and it's not clustered or it's stratified. A simple random talks about
Just randomly selecting.
randomly selecting of all the population, so there's no bias, so everybody has an equal chance.
Yeah, I'd agree with simple random.
Alrighty. Question 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge the opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random of 100 people. Then they took a list of registered Republicans and selected a simple random of 100 people. Which type of sampling scheme was implemented?
Probably stratified, right?
Stratified.
Or stratified. Yeah, not stratified.
Yes.
Or, oh, I didn't see cluster. I always miss the very last one.
Yeah, I know. It's kind of tough. Adequate gauge opinions on both sides. Democrats.
I think it would be stratified because it divides them into similar groups and then takes it rather than cluster. It seems like it just says it takes all of the items from different areas and combines it.
Right.
But this one
Yeah.
is Republicans and Democrats. Yeah.
So it's stratified because it's on their own sampling, right? According to their party line.
Yeah. Okay. Ready for number 8?
Yes. Yep. Stratified it is then.
Okay. All right. So using software, calculate the mean of the amount spent.
All right. Let me pull that up. The Crossroad purchases. Explore.
Oh, I think, wasn't this in our review?
Let me see. Which part?
So number 8, I know it asked us to pull up that same thing in the review yesterday, or the review.
Yeah. I think so. I think these questions are all the same. I think.
Yeah, they all sound pretty similar so far.
Did you get mean of 4.771?
Yes.
4 point, okay. 4.771. All right.
Round to 3 decimals. Oops. 4.771. Okay, there we go. And then the standard deviation, I got 1.911.
Or, well, I guess the 9's right behind the 1. Would it be 1.912?
Oh, yeah. Yeah, when I did the review, I didn't really round
Yeah.
any of them.
That'd be good for the test, because
1.912.
and then does it ask for the median?
For the median?
Or does it just ask for, oh no.
Yeah,
Oh,
it's just the mean and the standard deviation.
Okay. All right, so create a histogram. Okay. Perfect. Let's go to graph. Histogram. Perfect. I created a histogram. It looks great.
Just 1 second. Let me.
Do you remember how to get there?
Yeah, I created one last night, but it sounds like we have to do another one. So
you go to the graphs, and then you click down to legacy dialogues. and
Okay,
go.
one
Oh,
one
sorry.
sec. Yeah, it's just trying to pull up on my VMware. Okay. Oh, this isn't. Oops. I need to change my ending so it's the right document. It's thinking.
He doesn't want to do it, huh?
Well, I ended up pulling up the Crossroads before
Yeah.
it said .sav on the end.
Okay.
So then I had to go and pull up the right one.
Gotcha.
Oh, slowly getting there.
It's kind of a slow program.
It really is not my favorite program to use.
Yeah, not the easiest.
Mm-mm.
But you paid $50 for it.
Mm-hmm. Well, are you just using the software from BYU or did you actually buy?
I bought it. Are you
Okay.
use the software from BYU Idaho?
Yeah.
Oh, okay, so that might be a little different. It should be the same template and everything should be, but you just got BYU Idaho.
I know. I'm just like, I don't know how much I'm going to use this in the future, so I won't worry about buying it.
Well, it's only a 6-month lease, so you actually don't buy it.
Oh, it's almost like you're
Well,
renting then?
yeah, basically, you pay $50 to rent it.
Wow.
Yeah,
Okay, now I'm finally here.
you got it.
Okay, so it's graphs, legacy dialogues, and then down to histogram.
Correct. Got it.
And then we're looking for the amount, right?
Um, yeah, you're just I just wanted to know if you did create a histogram.
Oh, here we go. Okay. Yes, I created a histogram.
Nice. Yeah.
Okay. All right. You get to move on to
Yeah.
11.
Yeah.
Okay,
Yeah.
perfect. So Jessica Mayer and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals. The seal's body temperature at the start of the dive was calculated to be.
Perfect. All right. So I don't think it gives us the mean, but we do have to find it. Just calculating the 4 values together and then minus the sample mean.
Mm-hmm.
So we'll have
Yes.
to know A and then B. Okay. So we add them all up and then get our mean.
Which is 38.075.
I think so. Is that what you got?
Yeah, because it's the exact same numbers from the review.
Oh,
And
yep, 30.075. 38.075.
oh, okay, I'm like, wait, 30? Yeah, 38.
38,
Mhm.
okay. So then we take 37.91 minus 38.075.
Mhm. Did you get negative 0.165?
Yep, negative 0.165. Negative 0.165. Okay. Then it's asking us for B, which is we got to do 37.
I think it's 0.681
0.681. Okay.
from homework. Because, yeah, it's still 3 decimals.
Okay, so we do that. It's the so I took 37.25 minus 38.075. I got negative 0.825, and then I square that, or
Um,
right to find B, the third column.
yes.
So I just take that and square it. Okay.
Yeah.
All right. Square negative 0.825 is, oops, okay, negative 0.825. Oh, oh yeah, square, not square root.
I
0.825.
know those can make a huge difference.
Oh, they do. Oh, what did I do? Did you get negative 0.68 1 for your answer?
Oh, negative?
Or my bad. It was it. So we just do it's the squared, right?
Uh-huh. Yeah.
Okay, let me do that again.
Okay. But yeah, I did get the 0.681.
Okay, 0.681. That's right.
Okay, 0.681. All right. And then what quantity is equal to the sum of the numbers in the squared deviations column? And that the question that's asking, it was kind of confusing last night when I was doing the review, so I'm not 100% sure. Because it's not the mean, but it wouldn't be the standard deviation either, would it?
I'm sorry, I'm 13.
Yeah.
What quantity is equal to the sum of numbers in the squared deviations column?
Because wouldn't A be the standard deviation?
Oh, the mean you're talking about, or
Well, A would be taking the mean. Wait. Yeah, wouldn't A be taking the mean away from the X column?
I think so. A would be so A is mhm. A is the mean. That's right.
Oh, wait. I thought A is the standard deviation, though.
I'm confused.
I know it. I ended up just putting it varies last night, so I'm like, I don't know.
On the review on the lesson that they had on lesson 3. Just trying to get an idea about that.
Because you know how we had to find the mean on our own, like from column A by adding them all up and then dividing by 4.
Uh-huh.
But then I believe the middle column, deviation from the mean, I believe that would just be the standard deviation. And then the last column, it sounds like it's, I mean, the deviation squared, but would that be variance or?
I think so. In order to get the standard deviation, the square deviation from the mean. So, in column 3, the answers that you get, you take the sum of that, which is the sum is, I think it's the variance. And in order to get the real standard deviation, you have to square the variance, and then you get the true standard deviation.
Okay, so probably the variance then.
I think so. That's what I thought when I did the preview. So I think it's the variance. Okay, so we have to. We have to get all the answers on these ones then at the end. In order to get the standard deviation, I think you have to take the sums of the deviations and then square it.
So would it just be would we just be taking like 37.91 subtract our mean squared?
I think in the review, what it says to do is you then get the sums, and then after you get the sum, you yeah. Let's see. Huh.
Because for the first one, did you get 0.027?
0.027. So, refresh my memory. What was the mean again? Sorry.
38.075.
Okay, yeah, I got it. Okay. Okay, so 37.11 minus. That. So how did you get the first column? Was the second column?
So the second one I got was 0.681.
0.681.
Yeah. Wrong button. And then the third one, I got 0.007.
0.007.
Uh-huh.
The third one?
Or
Okay.
the fourth one. That's what I meant. Fourth.
Oh, the fourth one. The first one is what is it again?
So Bodil, I got, well, I don't know if that's the same on here. Is it Bodil as well? Yeah. Okay. So for Bodil, I got
Yeah.
0.027.
Yep, that's what I got. 0.027.
And then Roberta, I got 0.681.
Yep.
And then Larry, I got 0.819.
Yeah.
And then Per, I got 0.007.
Okay. So then I think I'm looking at lesson 3, right?
Hmm.
I'm just saying if I look at lesson 3, right, I think we take the sum of that, right?
Let me get back to the question.
Take the sum of that. 0.027. 681 plus 0.819 equals 1.534.
Would it just be adding all those together then?
Yeah, we add them together,
Okay.
and to get the variance, we take the sum equals 1.534 over n minus 1. So we take the number minus 1, so 3 minus 1, or just over 3.
So, sorry, after we get the 1.534, we put that over.
Yeah,
And
we could, yeah, that's to get the variance, and then we take the true variance, and then we square it. I think.
so square the 1.534?
Mm-hmm. Yep.
Okay.
Or no, we have to, I think if I'm looking at it right, we have to, we'll divide that by, so there's 3, 4, we'll divide that by 3.
Wait, divided by 3?
I think. So I'm just looking at the lesson and what it said. Um, yeah, that's what we do. 5, 1, 1. Yeah,
Okay.
yeah, I think that's what we do. So if you look back up on lesson 3,
Lesson
talked
3?
about, yeah, so we take
Okay.
the variance. And on this, question is asking us, what is the standard deviation? What I did is I took all the, I got 1.534. Then I divided by 3 because it tells us to do our values minus 1. And so I had 3 after that. So I divided by 3, and I got 0.511, and I took 0.511, and I took the square root of 0.511, and I got 0.714. But if you round up, I got 0.715.
Okay, so now, was that formula in the lesson 3?
I didn't necessarily see it, but I think that's how you actually give it, though. Because this goes so far as the square deviation from the mean. And she's asking just for the actual standard deviation, which I think it is. But I can, let me take the,
Yeah, I believe you. It's just,
oh, I know what you're saying. It's just not here. There's not much clarity here. I can take those, I can plug them into Excel real quick, just to make sure. One, 2, 5, 8, 9, 8, and 6. Okay. Huh. Yeah, I think it's right. I don't know. I'm not 100% sure on this one. So
okay.
I'm not 100% sure.
Okay. Yeah, I'm just wondering, like, where you found that formula. So, like, if there's a question on test like that,
Yeah,
I'll know, like, okay, this is how I do it.
I found like on just from a book I have, another statistics book, but it, yeah, it's not really. I don't know if there'll be one like this on the exam, but I think that's how you do it. If I had the mean right and everything,
Okay.
I just don't 100% know if that's what they're actually wanting, or I guess I think so, but
It's hard
they
to
might
tell.
say if I'm wrong.
Yeah. So now, okay, let me just see if I'm getting this right. So we got all of the little numbers for column 3, and then we added those all up together and then divided by 3, and then we square rooted 5.11 to get 7.14.
Yeah, but then you just round up to 7.15 to,
Okay.
because it's 0.7148, I guess. Yeah, 0.715.
Okay.
Is that all right? Hopefully it'll be all right. I don't know.
Yeah. I know that one was kind of confusing last night. All I put was, oh, it varies, so I don't know.
Yeah. Ready for 15?
Yes.
Says under certain conditions, the standard deviation can be negative. That is false.
Isn't that false?
Yeah, I think it's false because there's no way the standard deviation can be negative, right?
I don't think so. I know the whatchamacallit. Like I know z-scores and whatnot can be negative, but I mean
Yeah, because they go
they
in the distribution, but as standard deviation, it doesn't make sense because kind of like the probability rule, it's either between 0 and 1.
uh-huh. Yeah.
Negative sound okay?
Yep, for false.
Okay.
Okay, so in the same study, the researchers placed thermistors, temperature sensors in the 3 seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Sammy, Nut, Jonesi, and Butler in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals named Bodil, Roberta, Larry, and Purrit in their hepatic sinus. The results from the study are summarized in the table below.
Okay. The mean standard deviation, the sample size is there. And question 16 asks us which location resulted in the most consistent temperature measurements from one seal to another.
Oh, isn't it extradural?
Extradural, yeah. Sample size is 3. The mean is 37. 47. Yeah. The least movement would be the lowest standard deviation, I believe.
Mm-hmm.
Right? So it would be, like you say, extradural.
Yeah.
The most consistent measurements, yeah. Right. Okay. On to 17. So, those are the box plot. What is the third quartile?
Wouldn't it be the 8?
Yep, it's the 8. That's right.
Because isn't it the very ends, like you have your so your 2 and the 12, aren't those your minimum and maximum?
Yep, then the 4 is the first, 6 is the medium, the 8 is the third quartile.
Okay, perfect. What percentage of the data lies between 4 hours and 8 hours? Note, list the number as a percent and not a decimal, and don't include the percent sign.
Okay. So, if you think of a quartile, 44 is 25%, 8 is 75%, so it would have to be 50%.
Oh, because you just subtract the 7 or 25 from 75?
Yeah, because the majority, that's how I figured that out, because you have 25 and then you have 75. And
Yeah.
so you have the data lies in between those two.
That makes sense.
This next one, it didn't make sense to me at all. I'm not sure about it.
This one.
Kind of tough. Were you able to figure it out?
I'm just trying to pull it up from last night. Let me see. So it's question
19.
19. Estimate the mean. For 20, I ended up getting 2.0, or sorry, not for 20, but for 19.
19?
Yeah, I got 2.055.
Okay. I just wasn't sure how to go about it because it says the drinking water is between 1.59 and 2.52. You just take the two rows, the sum, and divide by 2.
Yeah, I think I ended up
2.055.
yeah, I got yeah, 2.055.
Okay. Is it? Yeah, I just wasn't sure what to think because like it doesn't give us the mean here, so I guess it's one of us to get it out of it.
Cause okay, so standard deviation, did it end up giving us?
It says an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean.
Mm, yeah, I'm just trying to remember how I ended up getting that last night.
Well, I took 1.59 plus 2.52, and then you divide by 2. And I got 2.055.
Okay, maybe that's what I did too. I can't remember.
I
Okay.
guess that's how you get that's what they're asking, is around your answer to 3 decimal places. So I guess it would be that 0.055.
2.055. Yeah.
Okay.
Okay. So now find the standard deviation. I got 0.465.
0.465.
Yeah,
Okay.
I don't know if that's right or not, but
How did you get that?
how did I get it? Or
Yeah. How did you get 0.465?
so I think what I did was, let me see. I think, okay, so either way, so I just took the mean that we got and then I subtracted so I subtracted the mean from like the first one, so the 1.59. Okay, so I did our mean minus the 2 times. Oh wait, no, that's for standard deviation. What did I do? Now I have to try to remember what I did. Hold on. How did I get the? Oh, that's how I got it. Okay, so I just took the like 1.59 and I subtracted the mean 2.055 to get the standard deviation. I don't know if that's right though.
Yeah, I'm just wondering how to get it. Because it talks on the information, there's 2 standard deviations, so of it having 2. So I'm wondering would it be 2 standard? The standard deviation be 2? I just don't know.
Well, are you getting the 2 from the little paragraph?
Yeah, I'm curious how to get the thing division because they don't give us any other information. Unless we have to take these 2. Other predictions and find the standard deviation.
0.93. Oh, maybe this because it gives you the little formula, you just take the mean minus 2 times the standard deviation. And I wonder if we just plug in the your mean
Oh, okay.
and then get the standard deviation by itself.
Okay. Yeah, that could be. Let's do that. So you take the mean, which is 2.055 minus 2 times 2. 0.11. Is that right?
Possibly. Hold on. Let me see.
It's multiplication first, so it would be
Hmm. Did you get 1.125? Trevor?
how did you get your answer, Sarah?
Oh, okay. I think you froze for a little bit.
What's that?
Did you get 1.125?
No. So you take the mean, which is 2.055,
Uh-huh.
and you times, are you minus 2? Or what do you do?
Well, like it says the formula is just the mean minus 2 times the standard deviation,
So the mean minus 2.
but I'm just trying to remember how I even went about doing this last night. Oh.
Yep. A little tricky. I'm not sure what they're running. I have no idea. This is not really explicit at all.
Mm-mm.
1.5.
Because I wonder, it would probably, once you do that formula, it would have to add up to the 1.59, right?
Yeah, that makes sense.
Okay.
Okay, so minus 2.
So that's like minus that 5, and you would just that's 4 times, we'd have to divide by -2. Okay. Let me see if I've. Okay, so I ended up getting -0.2325.
What's that?
I ended up getting -0.2325.
-2.335.
Yeah, I don't know if that's right or not, but
0.055 minus 2 divided by, oh my goodness, I don't know on this one.
I know it's
I mean, I plugged it into Excel and it gave me a standard deviation, but I'm not sure if that's what they're wanting at all. You know, I don't know. What I got in Excel was,
I ended up. Oh, sorry.
oh, sorry, no, that's okay. What I got in Excel was 0.658. I don't know if that's right.
0.658.
Yeah, that's what I got. 0.658.
Hmm. Yeah, I don't know because I I don't know if I even did it right, but I just took the formula that they gave us and I just kind of plugged it. So I did like for the 1.59, I just did 1.59 equals the mean, so 2.055 minus the 2, and then we don't know what the standard deviation was. And then I just subtracted the 2.055 from the right side and then subtracted it on the left side. And then I divided the left side by 2, -2, so I could take that away and just have the standard deviation. And then I got the 0.2325.
0.235.
Yeah, which I guess if we wanted to test it out, we could just put it in um, the formula and then see.
Let's see if it works.
Yeah,
Okay, so what you got was 2.235?
point 0.2325.
3235. Okay.
Yeah,
All right, so we'll do 2.055 minus, let's see, 2 times 0.2325. Yeah, that works.
and did it come out to 1.59?
Yeah.
Okay, so maybe it's the 0.235.
So what you
I'm
did
not quite
is
sure.
you did
What do you think? Maybe just stay with the.
or do we need to, what, 3, 2,
Oh, to round.
or would it be 0.233 because
Yeah, 0.233. I mean, point two. Yeah, 0.233. Oh, are you still there?
efficiency approximately 98% of the data values lie.
Would we just use the applet?
Going to be 0.233.
Let me see. So it's question 22 on the review. Um, yeah, would it be the third one?
0.9, and I think it's just the data values that they gave us. I think so.
Yeah.
Between those two values. Yep.
Okay.
Yep, we're good.
Awesome. So the third bullet point then.
The 1.59 and 2.52.
Okay, perfect. Okay. We're almost done.
Question 22. It's a little longer. All right. The admissions committees for most master's programs require the graduate management admission test as part of the application for new students. It has been shown that the are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in school accountancy at the IU is 500, but it is rare for students with less than 600 to be admitted. Okay. Alrighty. And question 22 says, what is the probability that a randomly selected student will score above 542.3?
So I ended up getting 0. I don't know if that's right or not, but
Yeah. What did you plug in for your X? Was it 500 or 600?
Well, I ended up just subtracting, so the number 542.3 minus the mean of 542.3 divided by the standard deviation and got 0.
Okay. I think the probability, I think we have to take the, when we get at the end, put it into a z-score, but let me see. Because is it asking that we put 500 minus 540? 42.3? I think
That's a
we're
good
onto like
question.
z-scores now and stuff, because
Yeah, well, I don't know, because if we were to find like a z-score, wouldn't we also need the sample of how many are being sampled?
oh, right. We're just doing probability, right?
Uh-huh.
I think, yeah, this is like lesson 4 where it's just about probability. But we do have a standard deviation, though, so that's what I'm wondering if we're like on to, let me see. So on the, I did 500 minus 542.3, and then divided by 120.54, 0.351, and I'm gonna plug that in. If it, well, this, see, experiment here. Negative.
Oh, did you not use the mean then?
I did. I did 500 minus 542.3, and then I divided by the standard deviation of 120.54.
Oh, okay.
You see what I'm saying?
Yeah, and you got negative 0.35. 1.
Yeah, negative 0.351.
Okay, I see.
And I think in the applet it's going to be on the negative side. So on the far left,
Mm-hmm.
0.363. 363. I see. What is the probability that a randomly selected student will score above? So if we're using 500, so I don't think we're using 600 yet. We're using 500 as our value. And so for those that usually get that would score above the mean. Let's see. I think it's 36%.
Wait,
363.
0.633?
Yeah, 0.363.
Oh, 0.363.
Yeah, 0.363.
Oh, yeah.
You see what I'm saying?
Uh-huh.
Okay.
0.36. Okay, awesome. All right, what is the probability that a randomly selected student will score below 600?
In this one, I think we just take the 600 minus the mean and divide by the standard deviation. And then we go, we get what's behind, below that 600 mark.
So would we do the z-score formula?
Yeah, the same as we did with the other question.
Okay.
We want the probability of a randomly selected student. So then we just do the 600, 2.3, 20.54.
Did you get 0.479?
I got 0.479.
Okay, perfect. And then it was a probability that a randomly selected student will score below the 600.
Makes me wonder because there's two possibilities. It's either 0.684 or 0.316.
Mm,
And
yeah.
it's not like the middle and the far left or just the far left.
I wonder if it would just be the far left because the in between the red lines, isn't that all considered the 600?
I think so.
So maybe it'll just be the 0.316.
I think so.
Okay.
So because this next problem would almost be the same answer. I'm just wondering if this one right here would also include the middle part. I just don't know.
Well, I think the next one, it's including the middle and the far right.
Okay, so this next one it would include the far
Yeah.
right.
Mm-hmm.
Okay, so then that would be 0.684.
Yes. Yeah, that's what it sounds like.
It includes it because, okay, so it's everything above the mean right there. Okay. All right, and this one, find the GMAT score that corresponds to the 10th percentile. So this will be the far left. Plug in 0.10. I got 1.282.
Okay, one. Yep, 1.282.
1.282. And
Oh,
on these ones, we time.
oh, doesn't it say round to the nearest whole number though?
Oh, on this one.
Mm-hmm.
Okay. Actually, it'd be negative 1.2. Or the answer. I think the answer will be rounded to the nearest whole number.
Mm-hmm. So just one.
Well, since it's in the far left, it's going to be negative. But that's not our answer yet, because we have to do the algebra and times it by the standard deviation, and then plus the mean.
Wait, I'm confused.
Okay. So you know how remember how to. So when we do the percentiles, what we're doing is you take you get the z-score, you plug 10 into the normal probability output, and then it's going to be on the far left, and we find that z-score is 1.282, and with that we times it by the standard deviation, and then what I got was since it's negative, it's negative 1.53.
Wait, sorry, you're cutting out a little bit. Trevor?
Can you hear me? Can you hear me?
Oh, you were just cutting out for a little bit, but now I can hear you.
Can you hear me? Okay, good. um, okay. Do you get how to do this problem?
So now you just take the 1.282 times the standard deviation
Mm-hmm. And then plus the mean.
plus the mean. And you got 696.8.
Or, well, that would be actually, because I think what you did was it wasn't negative, so the negative 1.282 times 120.54. I think you did a 1.282 positive.
Oh, did you get a negative 696?
No, I got a 387.
Oh,
I think what you did is you didn't put the negative sign. Since it's in the 10th percentile, we have to.
oh, I see. Okay, so it's negative 1.282
Mhm.
times the standard deviation
Right.
divided by the mean. Whoa, now I got negative 0.28.
Oh, okay. What I did was I just 0.282 times 120.54. And then after that, I just added 542.3 and got 387.
Oh, okay, now I got it.
There you got it. And it says round to the nearest whole number, so I'm guessing it would be 388.
388. Yeah.
380, closer to that. Okay. Sounds fair.
Okay, next question.
26, all right. 90th percentile, so the same formula, same idea. We'll just change the number on the top. And it'll be in the far right. In the middle, I think, too. So 0.90.
I think it's just the far right.
Yeah. Yeah, it'll be the same z-score, but positive.
Yeah.
1.282 times 120.54 plus, it's going to be a big one. So I think it was your first answer, but just the opposite.
So did you get 696?
Yep. But it says rounded natural number, so would it be 697?
Yeah.
Question 27, first quartile, so it'll be the far left on this one. So that'd just be 0.25.
Mm-hmm.
Again, negative 0.674 times 120.54.
Yeah.
That's
Negative
42.
0.674. So would it just be the negative 0.674, or would we have to do more to it?
It's just on this one, it'll be like the other problems. We'll do the negative 0.674 times 120.54, the standard deviation. 542.3.
Okay. Oops. We'll do that one right. Okay. Negative 0.4 times standard deviation plus the mean. So 461?
Yeah, it says 461.5604, so is it closer to 461?
Yeah.
461, okay. Alrighty. Question 28. Okay, so it's just basically the same stuff, but just find the third quartile. So on the far right this time, 0.75. And it's just positive 0.674 this time. Times 120.54.
$624?
Yep, exactly. What I got.
Perfect.
24. Question 29. All right.
Now we would do the z-score formula, right?
Yeah. Well, the others have the z-score formula, but this is the sample mean of the z-scores. So that would, when you take the standard deviation squared on this next question. So consider that a simple random of 15 students taking a GMAT of sample means for all such scores. All right. Question is, okay. All right.
I think I ended up for the mean. Yeah, I think for the mean, I ended up getting 540. Wait a second. I make sure I'm looking at the right one.
Yeah, I think it's 542. Like we did on some of the other ones, it tries to be tricky. It's just asking for the mean because we don't have any other information in this one. Or we do the same. In this next one, it'll just be the 15 for the 120 divided by 15 squared.
For question 30?
Yeah, because it's asking the standard deviation of distribution of sample mean scores. And we just do 120.54 divided by square root of 15. And that should give us our answer. I got 31.123.
Yeah, that's what I got too.
You get that one? Okay. 31 point. Ask that question. Yes. All right. Oh, cool. So this gives us all the information we need. What is the probability sample mean in that score of an SRS? Sample mean of 15, it will be greater than 600. So just plug 600 minus 542. 542, my bad. Minus 542.3. And then divide that by 120.54.
And then square root of 15.
Yep, square root of 15. And then I can get the z-score. I got mine of 1.8.
And then we have to plug that in.
Yep, plug that in. 0.8. I got 0.3 or 0.032.
Yep.
Yeah.
Yeah, that's what I got too.
All right. Because I guess if it says greater, it would be on the far right side. Very far right. That's what I got.
Yeah.
Okay. Cool. Looks like we got it done.
Okay, let's see what we got.
See the damage. I think there's a few wrong, but I think we got it. Right.
Right.
All right, let's submit. Let's see what happened. %.
Back.
Let's just see which ones we got wrong.
13.
Okay. So 23 and 24 backwards. Where the 0.684 was meant to be with the 6. Maybe that's where those two were wrong.
Oh, yeah.
Because 600, I think, was way above the mean. That's okay. Maybe.
Yeah. Wait, you got an 83?
Yeah. What did you get?
I got an 80.
Oh, really? Which ones did you miss?
So I missed 23 and 22.
Yeah, me too. So I think, yeah, all right. Missed 22 as well.
Yeah, and then 14 and 13.
21. I got 21 wrong.
You get 22 right then, or no?
I didn't get it right. Huh, that's good. At least we were right on the standard deviation. We got that one right on question 14.
On question 14. Yay! And that question was when we their patients and then added them up.
Divide the sum by the value minus 1, and then you take that, square root it, and that's how you get your standard deviation.
Oh, okay, yeah, that's right. Wait, was that question 14?
Yep, question 14.
You put for your answer?
0.715.
Oh, I put the point
Uh,
0.15.
gotcha.
Uh,
I don't know why I didn't get question 22. I don't get that one. Oh, maybe it's because it was meant to be the middle part too.
for which question?
22. Huh.
Hmm.
Let's see. Yeah, and then 22 and 24, I think those were just turned around. I think since 600 was so high, it was way above the mean, that I think it had to include on 23 the middle and the far left. It'd be 0.684, then 24 would be 0.316.
Yeah, I could see that.
I just think about it because it was common sense that for me, be way less students, 31% that would score above 600 because it's such a hard score to get. And then, yeah, that wasn't bad.
Pretty good, honestly.
Yeah, then 21, I don't know why I got that one wrong. I don't get where that one went wrong. But
I wonder, maybe it would have to be a little like higher than the 1.5, but lower than the 2.5.
right, I mean, it says that since 68% is one, it has to be a little higher than that, but not more than one deviation. So maybe like 2.288, 2 minus. No.
Yeah, so it honestly would have to be either the first last bullet point.
Yeah, the first one, because it can be over one deviation, but it's that 68%. It just can't be over 2.
Oh, yeah, that's right.
Because when it gets to 2, that means it's 95%. So in that mark of 68, it's still a standard deviation of 1. Maybe 1.4, or it could be, but it still is that 1.
First bullet point then.
So I think yeah, number 22 would be, I think, A. And then I think where I messed up on possibly number 2 is that it encompasses the middle part as well. So,
Question 2.
what's that?
Or what question were you on?
22. I think where we may have gotten it wrong is that we didn't put it in the middle part as well, the shaded in. Let's see. No.
Well, wouldn't like we include the middle part if it says if they will score 542.3 and above?
What's that? I'm sorry.
For question 22, wouldn't we include the middle part if it said if the student will score 542.3 or above?
Yeah. Above the mean, yeah. I just was curious why, because we did the same thing, but it didn't turn out negative 0.351. So if we include it, which because it's very narrow, the middle part, it would be 0.6372. That a student will score above the mean. I don't know.
Yeah, that's a tricky one.
It's either that or the other one, and the other one's not right because I think it could be that. Because I mean, a 60% chance that they do get in.
That's probably the middle and the far right.
Yeah, I think so.
Then
And it would be that question is number 22. And so it would be, if you can retake it, the answer is 0.637. 637, that's what we got wrong. And then I think on 23 and 24, they're just backwards from each other.
okay, yeah, I could see that.
All right, so we're good.
Awesome. Well,
I think that's about it.
how to post link.
Yeah, I got it. No worries.
Okay, well, thank you.
All right, we'll see ya.
Tuesday. And good luck on the
Take
exam.
care. Bye-bye.
Thanks. Bye.